Welcome back, everybody. You've got the pre-lunch talk, so hopefully this will be an interesting one for you. So I'm going to be talking about, a brief talk, just 15 minutes today, but around GitOps and obviously simplifying container management. Is anybody currently working with Kubernetes or container platforms in their role? Okay, we've got a few people. Anybody interested in learning about it but hasn't quite managed to put it on the list? Yeah, it's quite a scary thing. I'm not going to lie, the learning journey is pretty steep. Definitely a good investment of knowledge if it's something that's going to help your career. But yeah, hopefully we can sort of simplify this, give you a little bit of an understanding of where GitOps fits into this. So we're going to talk about the common problems, talk about where CI/CD and GitOps then come together, and then how you actually manage those containerized workloads. So what's the problems? Do we have any developers in the room? Who are the developers? OK. So you're the people who say, I want full ownership of my application and its dependencies. Please stop telling me what to do, everybody. Like, we have a way that works. We know how this wants to work. OK, we get a lot of nods. And then any platform team people, SREs, anyone in DevOps? OK, so you are the arch enemies of the people that we just mentioned, because you're saying, please, can we have something a little bit streamlined, something that's centralized, like a one way of working? Why do we have to have 15 different DevOps pipelines? And it's interesting, because I sat in on the last few talks, and there was a lot around that, how you kind of find one managed approach to doing stuff. So you've got two very conflicting problems here. Now, I work as neither. I'm a solutions architect, so I'm not going to say that there's a wrong or right way, but I do understand that actually trying to solve this is quite complex. For people in small organizations, that's not too big, but, we heard Booking. I had no idea they had so many developers. I mean, is it 4,000 plus or something in that number? I can imagine being on the other end of making those decisions. So what are the problems that come out of this conflict in the middle? Well, so the first one is the automation. So kind of infrastructure management over large scales and over time, it gets a bit of a problem. We start with the old days of everything being manual. Some people sadly do still have to log into servers and manually update them and provision them, by hand. Thankfully, things started to move on, very time consuming, very error prone, definitely not reproducible. So we moved to scripted, and this is something that's been going on for quite a long time now. But there's problems with this too. If an API call fails, how do we know that it's working? How do you make updates? How to roll things back? And then obviously in recent years, and I've heard it mentioned a few times today, things like Terraform have come in. I mean, more recent, it's been quite a while now, but this is easy to automate. It's reproducible. You've got that configurable syntax. It's very easy to reuse. And once you learn it, you take away all the abstraction of detail, and you have those automated approach. And so we have this area of kind of moving from that low-level approach to high-level. So what's the next problem? Well, the next problem is consistency, and what is the single source of truth? And this is particularly difficult when you have multiple people working across configuration files, OK? If you have just one or two of you and you've got good documentation, I mean, who likes writing documentation? Nobody. We're hoping AI tools are going to come in and do this for us. But it can be really difficult to understand what the actual desired state should be and what is accurate. And then also when those vulnerabilities might have been introduced. And this isn't the blame game of who, but we still need to identify them. We need to know what the lessons learnt were. This can be really challenging. And then the final one is versioning. So, who made those changes? Why were they introduced? We can see that change was made. What was the thought process? Is there documentation for this? How can we track back? And then how can we potentially roll back when we need to? So this is where, to try and solve some of these problems, the industry moved a couple of years ago to using GitOps. Is anyone using GitOps currently? Have we got anyone that's using it? OK, so we've got kind of a half hand of yes, but I don't know if we're doing it properly, so I'm not going to put my hand all the way up there. But OK, so what is it? Effectively, it's kind of an evolution of DevOps. So it's where we focus on the application code. DevOps focuses on the application code. GitOps more focuses on the infrastructure and the provisioning of the infrastructure. And so just like we manage software code, i.e. we write all our code in a file and then we deploy it, we're now going to move to doing the exact same thing with infrastructure. For those who've used Terraform, this is that concept, right? We know that everything's done as code rather than us sort of, just having scripts to do everything. But now we use the same tools that we understand with software development in the form of Git to actually fully control the deployment using versioning and lifecycle history. So rather than just, say, writing a Terraform script and deploying it, we're now going to use Git in the exact same way we do with software development, and we're going to manage all of our infrastructure at the same time. We still then do have a CI/CD pipeline where we're going to automate the build and test and deploy it. And so the idea is that that desired system for the infrastructure is fully controlled in Git, and it helps to resolve some of those challenges that we just talked about. So as I say, just on that visual, for those visual people, we write our code. This is for sort of software. We know this, right? We commit it to Git, and then we know that that executes the CI/CD pipeline, and we get a new software version. We hope that it works. Hopefully there's no bugs, and on we go with our days, on to the next sort of pull request or the next merge request. We just now do the exact same thing. The process remains exactly the same, but now we do it for infrastructure. Now, one of the great benefits for this is that it means that people are using tools they are already familiar with. Aside from the things we talked around with automation and with sort of errors and rollbacks, we're also making sure that people are actually already familiar with Git. Most people know how to use it very comfortably. We're not trying to introduce new things. So we end up with this kind of continuous operating model where we have this constant element of sort of deploy, verify, observe, kind of alerts, operate, fix, and round the cycle goes. So from an AWS lens, and I know people may be using other clouds, but just to give you like a really high-level overview, this is what traditional sort of DevOps CI/CD might look like. You can obviously change out any of these AWS services with your own, but it looks something like this. Developer writes code, commits it using some sort of Git repository. For us, it's code commit, goes into code build or whatever it is that you're using. Let's just say in this example, we have Elastic Container Registry holding then our images once they're created, our Docker files. That then goes into a code pipeline, and obviously everything is sent over to EKS in this example, and everything is built. Now pay close attention, because what I'm going to show you looks almost identical, but there is just one sort of change. And I'll be honest, when I first looked into GitOps, I was like, okay, I don't really understand what the difference is. Like, what? I don't really, okay. And it honestly took a while of rereading, researching, and actually just playing out with things and going, right, I finally get it. It's a very subtle change, but that change is really impactful. And so what we get at the bottom is almost identical, but if you look at the bottom where we have that config, which is our infrastructure config, we have, instead of just having our EKS cluster, we now have something that's called a GitOps controller. And the job of the GitOps controller is to monitor the state of the manifest files or of the config files to always understand what the desired state is and what the single source of truth is. If we think about the one above, once you deploy a Terraform file out and you build your environment, it's built. If changes are then done to the file, you're relying on another push going out. And if things are changed at the source, you don't actually know that they've changed. The single source of truth is the state of the cluster. That might not actually represent the truth of what you needed, which is your up-to-date manifest files, your up-to-date config files. So this one small change, most of the pipeline remains the same, but we actually employ a controller to do this constant loop back, where it will constantly check and say, is what I've got true to what it should be? And as any changes are implemented, does that always marry up? And what it then can do is it can make the changes in your cluster in line with the most up-to-date file. So any changes are constantly going to be reflected. So there's a few different ones that you can use. We'll talk about them very high level in a moment. But effectively, what we're now going to have is something that looks very much like this. Very old diagram for anyone who loves the old symbols, but it's the only one that I could find about recreating it. We just now have two Git repositories, one for all of our application code, one Git repository for all our Kubernetes infrastructure, and we're going to just treat them in the same way. And as I say, the first bit remains the same, the software development part, but that Kubernetes element, that being able to use the GitOps controller, is going to keep that constant desired state. So there's a couple of different ones. Flux and Argo are the two most used. I would say, controversially, that Argo is probably the kind of, the one that's really taken off. It seems to have the most community support. It's definitely got, and actually the team outside of Octopus Deploy can definitely talk to you a lot more about what Argo are doing. But both of them work, as I say, in really high level. There is differences between them, but ultimately they will look at those Git repos, they will look at your infrastructure, they will reconcile any changes between them, and they will update your infrastructure if needed. So if we give an example, if a Kubernetes manifest has changed the pod spec and it goes from 1 replica to 2 replicas, then obviously the controller will kick into action and make those changes using the Kubernetes API. And we have this constant source of truth between the two. So looking at this then from the container workloads perspective, so this is what it could look like with ECS. So we talked about EKS, and what I would say is, and I'm going to caveat this by saying, GitOps works beautifully with EKS. It doesn't have the same power with ECS because ECS isn't designed to be managed in that very fine-grained controlled way that you have when you're using Kubernetes. That being said, you can still kind of have an adaptation of ECS so that can work for those who are working with ECS instead of EKS. I'll give an example here. So obviously with this one, we can see that we've got our Git repository that's still holding our YAML file, so all of that remains the same. There's actually a great blog on this, and what it can do then is it can kick in step functions, and it's able to then take those changes out of your Git file to still deploy them into your infrastructure without having to go through the sort of traditional thing that you have before. So you're still going to have that automated deployment, and you're still going to be able to update your Git repository and automatically kick off some step functions to change your infrastructure for you. What you don't have is that controller element. There isn't currently support for things like Flux and Argo where it's then going to constantly kind of manually look back. So it sits somewhere in the middle between having to kind of like set up the deployment and having the complete infrastructure controlment, and it sits somewhere there. But definitely is a little bit more aligned for EKS, but just wanted to show the example of ECS and see where it fits in. So very quick introduction to it, but just to understand, totally forgot that those were on there, so there we go, some notes. Just to understand, those main problems that we had at the beginning. The first one was automation. Okay, we don't have to set off deployment pipelines. We update our config, we use our push command, everything else is going to happen automatically. It's worth noting for those that are saying you are not putting infrastructure changes in without me checking, like no way. You absolutely can with Argo, and the same with Flux. You can have those manual interventions. You can have those touch points that you put in where you say, I trust it like this much, but there's this bit here that I'm not risking it. And you can actually still have that manual intervention just to make sure that what you're doing is safe. So those are obviously completely optional, but it still can take that full automation if you need it. Obviously, the consistency, so having a consistent approach, this is a very easy thing then. It doesn't matter kind of the dependencies, the software code that you're dealing with. Obviously, from the infrastructure side, you have a consistent way of dealing with stuff and rolling out across your environments. And I think most importantly is versioning. I think when something goes wrong in an environment, trying to troubleshoot where that came from, where that was introduced, being able to quickly roll back. These are the great things that developers will tell you about why they love working with Git. We're just going to take those same benefits and we're going to apply them to our infrastructure. I think as more and more people move to the cloud and as more and more people take advantage of the cloud scalability and elasticity and that ability to quickly tear stuff down and try new stuff, that ability to have that full version history of everything that was done, every merge request, and take advantage of using Git in the way developers have for a long time is really powerful for people. So I'm going to stop for now and take any questions, but hopefully that was a nice introduction on GitOps with containers. Thank you.
Is there any plans to run Argo CD as a service within AWS? Because obviously if you're using GitOps, you're managing your own Argo cluster.
Not that I've heard of at the moment. The best place to look for anything container related, if you're not following it already, is there is a GitHub container roadmap, and then it often will talk about kind of the services that also sit on the kind of crux of that. There isn't any talks at the moment for doing that, but that might change in the future.
Okay, thank you.
No problem. Any other questions? Oh, got one over here.
You mentioned before in terms of the repository structure where it was two repositories, one to manage the Kubernetes configuration and the other to basically application code. How would that work when it comes to adding new infrastructure components or resources? Let's say you want to add something like Elasticsearch, but then there's a code dependency or code integration with that. Would they be ideally in the same repository? And then how does that then get rolled out? Because you've got a bilateral dependency there.
I'm not sure is the answer, so I'm not going to make one up. I'm not sure, but I can go away and have a look and come back to you on that one. But yeah, not sure the answer.
No, it's like...
Okay. Well, by some miracle, I actually did that on time, given that that's normally a 25-minute talk with a lot more content. So in a moment, I'm actually going to hand over to Miriam from Salem. Before I do, though, I just wanted to take a moment to tell people about, I guess, some of the work that we've been doing, obviously with Miriam coming to talk. So I and some others started the AWS Cloud Women group in Manchester. So I don't know if anyone's heard of it, but there's a monthly meeting with AWS Cloud Women. It isn't just for women, it's for anyone who wants to be an ally for women trying to grow their kind of careers and their place in tech. We've done everything from architecture catters to nights talking about advancing your career, technical talks, the whole lot. Obviously, you can find it on LinkedIn, you can find it on Meetup. But the idea was that obviously there are less representation, arguably, sometimes on some of these speaker stages, and there's lots of amazing women out there doing some incredible engineering work, incredible technical work, and it was a chance to give them a voice. So part of what we did was we actually ran an AWS Cloud Women public speaking course, which was open to anyone who wanted to just get better at public speaking. And a big part of it wasn't just how to speak publicly, because that you can kind of watch on YouTube. There's nothing new we could add. But it was about, particularly if you wanted to maybe work in the technology domain for speaking, how to tell stories, how to think about writing talks that the audience would be interested in, how to make sure that what you're talking about is actually audience-centered and not just you talking about the things you think are interesting, but really sort of breaking that down. So they may run them again, but I know that AWS also, the general meetup group, does similar things. But it was just a moment to share with that. Miriam actually didn't do the course on this occasion, but also has done public speaking before, but does come along to the meetup group. So we'll both be about. I'd be happy to come and kind of talk to you if it's something that you're more interested in doing. But yeah, we'll just have a moment or two to get Miriam sorted, and then I will hand over to the next talk. But thank you very much for listening.